My name's Tim. I'm going to talk a little bit about unit testing and mocking, which I consider are sort of two things which go together very well and will make you a much better developer. I would argue that this is something that will really improve your code if you don't do this already. Oops, why can't I go to the next slide? Okay. But why should we bother? Because programmers apparently are lazy. And if you're not, you should be, so just Google the 3 virtues of a programmer. Basically that says that programmers don't like to manually do things. They don't like to sit there and copy and paste things all the time because they're programmers and they can find a much better solution for that. And testing provides a much better solution to making sure that your code works as opposed to a manual process. Because manual testing isn't much fun. And I already said that, in my opinion. So manual testing, I work primarily with web development, so my concept of manual testing would be going into a product and refreshing a page and creating some different code and just going through that, and essentially you're just wasting your time. People always need more time. That's kind of something you realize when you leave school and start to get a real job. Suddenly you need to be as optimal as you can with your time. And it's a very, very fragile way of verifying the correct operation of your code. It's impossible to manually test effectively. You'll spend hours just refreshing web pages and very little time actually writing any code if you're going to test that your code works properly. So here's an example of, we'll just go through Tumblr's login page. Pretty standard stuff. You enter email and password and it logs you in. So if you didn't enter an email and password, you probably want to make sure that you got a nice error message like that and that it didn't actually log you in somehow and things like that. Hopefully you can all see that. And also if you put in a crazy email but left your password blank, you'd want to make sure that it displayed you a nice error message, didn't do anything weird. So the way that you could do that is edit, save, switch to browser, refresh, enter login credentials, submit. Doesn't work, so you repeat that whole process over and over and over again until you get something that works. But that's lame. You don't want to do that. It'll take you forever. And then if you have a different situation, then you have to do it all again. And if you want to add something new to that login form, I don't know if you want to change the error message or add another field or something like that, then you need to make sure that everything else that you didn't touch still works. And it's actually fascinating how often you think that two things aren't related and you'll change one thing and then a load of other stuff breaks, and you would never know that if you didn't go and manually test all of those things. So the solution is to have a nice little test suite, and you make a change, and even if you don't think that change is affecting anything, you just run your tests and it all looks good. So I've been talking about unit testing, but I haven't really explained what it is. And essentially what you're doing is breaking your code into very small chunks, so usually a method or a function, and verifying that each of those chunks of code does what you think it does. And every language has a library for testing stuff. In Python we have one called unit test, which works very well. And we're not going to go into that one because I'm going to show you a few examples of unit testing in our. So you're probably all very happy that I've done with the slides because I tend to talk just what's on the slide. So okay, we have here a function, really simple. It's called, in fact this isn't the one I want to show you. I want to show you this one first. So I have a very simple function. It just splits a string on white space and returns a list of the tokens in that string. So if you have a little sentence there like input this presentation is great, it should return a list with each of those items in it. And the reason I didn't use string.split is because that's a built-in, and you didn't need to test anything that's built in. You have to assume that they're all very well tested already. So I'm using a regular expression there, just takes the input and gives you an output, pretty simple. And so then I also have down here a little unit test for this, and the way that unit test works is you just import it up the top there, import unit test, and then you create a class and you extend from unit test.testCase, and then you define methods on that class which begin with test underscore, and then after that just something descriptive for your test name. And they should exercise the function which you want to test with a known input. And then you have an assertion, that self.assert equals, that asserts the output with what you think the output should be. So in this case, we're passing in foo-bar baz, and we expect to get out a list, foo-bar baz. And if I run that test like this, we see it passed. So that's good. We can, double check that that didn't pass just by chance. Oops. And it failed. And it tells us why it failed, because we used assert equal. It says there that I put a load of rubbish in one of the things. So that's good. Oops. So, super simple, really. That's all unit testing is. I mean, you're just making sure that stuff works like it is. I mean, you might, if that was a more complicated function and there was a few other ways that you could give input and you're expecting output, then you might want to have a few different tests that actually test the same function. But in this case, super simple. And the great thing is it runs really fast. Like, you could have hundreds of these in your code testing all sorts of things, and they would run in just like a fraction of a second, which is what you want. If your tests take a long time to run, you won't run them, and as soon as you stop running a test, that's a bad thing. So let's jump back to the presentation. So as I mentioned, one thing that goes really, really well with unit testing in particular is mocking. And what mocking is effectively using fake objects to isolate the behavior of an object under test. And so if you have a function that calls other functions, you don't want to test those other functions. You only want to test the function that you're currently testing. So if your function that you're testing calls another function, what you can do is mock that other function, so just return a known value. Seems pretty simple. So if the function you're testing calls a method on another object, mock that object method, because you should have another unit test which tests that function. So you don't need to test things twice. It's quite common when sort of starting out with testing, and particularly, so I work a lot with Django, a web framework, and you can write tests very easily that that sort of test, how can I describe it? Test the same thing over and over again. And what will happen is you'll get a failure in that code that gets tested repeatedly, and then all your tests will fail just because you had a syntax error or one thing that went wrong. It's like, I call it like binary testing. If you have something that goes wrong, really only one test should fail in an ideal situation. Whether you can ever actually get to that, I don't know, is another thing. So another useful application of this is, I work for a company called Photojournal, and we build blogs for photographers. And we do a lot of uploading photos to Amazon S3. And in our tests, we don't want to do that, because I don't want to sit there and wait for a photo to upload to Amazon S3 and then verify that it actually works and things like that. So what you can do is we'll mock the function that uploads to S3, and we'll say, we'll call that, and we'll just know that it worked, because the actual upload to S3, you might test that once, but you wouldn't test it every time, right? And you also might want to fake a database. Database access can be slow, so you could just use mock objects to fake access to database. And so I have a couple of examples of using mocks to mock calls to the internet, because Brian mentioned, what was it, about writing Python on a plane. If you're writing Python on a plane and you're building a web product, you don't want to be hitting the internet because, well, I suppose it might work on some airlines, but you don't want to do that. It's going to be really slow and awful, and you're not going to be able to run your tests, or going to fail. So here I have an example of another function. It's called HTML Fletcher, and as you might imagine, it just goes to the internet and it accepts a URL and it returns some HTML. So it uses the requests library, which is a very nice library for interacting with the internet. And simple, it just gets that and returns it. I have, let me see. And we have, well, I won't bother. Basically, it's hitting this website, which is my test page on my website. It's just returning this little snippet of HTML, just super basic. And so we have another test for that down here. And this test doesn't use any mocks. So it hits the internet. It passes a URL to the function, goes off to the internet, returns that HTML, comes back, and then it asserts that using this assertion line here, it asserts that what the text of the object that's being returned by requests is equal to what we have here, this copied and pasted HTML string. So if we run that, it passed. You see how long it took though? It took like a second. If you had 100 of those, you're going to be waiting 100 seconds. So obviously you don't want that. So we can mock requests get method and say, okay, we don't need to test get, and effectively that's what we're doing here. We're testing the get method of the requests module. We don't need to do that because it's written by a professional and it's got lots and lots of tests already. So there's no point in testing stuff that's already been tested. So let's have a look at an example of exactly the same test, but one that doesn't hit the network. And the way we're doing this is we're using another feature. Oh, in fact, I didn't talk about, I've missed out a huge part of my presentation actually, because I should have gone over a little bit about what mock was. So maybe we'll just, before we actually show you an example of mock, this is probably a good point to demo with. So, right, what is mock? Mock allows you to fake out parts of your test with known results. So if I have to import mock here, it's like, I think is it in Python 3 mock is included? Yeah? So I'm on Python 2.6.6, which is super old, but it's, so I have to import mock. And what I can do is instantiate a mock object. So if I say foo equals mock, and then I output foo. So foo is just a mock object and it has this ID, so you can compare different mock objects and see if they're unique. And what we can do is on this mock object, we can call arbitrary methods and so if I, literally any method, if I say foo is awesome, and then I pass me, or my name, I get a new mock object return. You'll see that the ID here ends in 8.4 and this one ends in 4.4. So those are different mock objects. And what we can actually do is assign return values to mock objects. So if I said foo is awesome and then dot return value is true, oops, and then I called foo is awesome, do I need to call it with it? Yeah, I do. Well, in fact, I can just call it without any parameters. And it returns true, because that's what we just told it to do. So that's good. So if you were calling an external function in your test, and you could just mock it like this, and it should be returned true, then you could just mock it to return true. So what we can also do is check, say, well, did we call is awesome? Oops. So we can actually assert that we did things to our mock object. Did we call the isAwesome method? Yes, we did. Foo isAwesome.called gives us true there. We can also assert whether we called it with certain arguments. So if I said, did we call, oops. Did we call it with Bob? No, we didn't. Did we call it with Tim? No, we didn't. I thought we did right up here. Oh, it's the last time you called it. Right, okay, so it basically doesn't throw an assertion. Yeah, thanks. And then there's a few other assertions that you can check, like was it called at all, and then and there's one other cool thing that you can do is actually test exceptions with this. So like it's quite difficult perhaps without using mock to actually test your exception blocks. So you have some code that throws an exception, did I handle that exception correctly? So we can do something like say foo.error. Side effect is what you would do. And then we'll just have a Django built-in error. And then if I call foo.error, oops, it raises an attribute error, which is great. That's what I want it to do. So now, if I had that in my test, I'd be able to test my, my exception block. So, now that we're all experts on mocking, we can jump back to, it was here. the actual test that uses a mock here. So this is going to not hit the internet. We're using, I won't go over in too much detail what this does, but this is a decorator which allows you to patch objects. And in this case, the way you actually use it is that, and this can trip quite a lot of people up when they're first starting to use mock, is that you use it where your object is your module is imported rather than where it's defined. So in this case, we're running this module as main. So main, and we're importing, if you look up at the top, we're importing requests. So we want to patch within this module requests. So we do that by patching main.requests. And then that will pass in a reference to the object that was mocked in here. And then we can just check whether our code actually did certain things to that mock object. So you might want to check that we called the get method, which in fact is exactly what we do here. So we just define our URL. We call our HTML fetcher function with that URL, and that returns some content. And then what we want to do is just make sure that as part of that, we actually called the get method with the URL. So pretty straightforward, because we don't need to test the get method in any way. We don't need to hit the internet. All we need to know is, did our function call the get method with the URL and thus would have returned some HTML. So we can run that test, and awesome. And if you'll notice how much faster that test is than one that actually hits the internet. It takes like, I don't know, it's consistent anyway. But the other one was this one. Takes however long. So I believe that concludes my presentation on mocking. Any questions? Anything make any sense?
Do you ever use create auto-spec?
In Python? No. No, not really.
So sometimes whenever you're mocking a lot of things, you can run into an issue where you change one of your dependencies and then your test will fail when everything's knocked out. So if you use create auto-spec, it will go and inspect the thing that you're trying to mock out. So if you change your dependency, it'll actually fail. If you do things like a cert call with, and you have a typo in there, without auto-spec, it'll just pass because
right, gotcha.
It's just a function called mock, but with create auto-spec, it'll recognize that function doesn't exist.
Right, yeah, I have heard of that, but I haven't actually tried it out. But it sounds definitely like something you should do, because yeah, you're right. That's one of the things that people like to say against mocking, is that sometimes it can be quite easy to have a problem in your code that goes unnoticed. Yeah, good point. Thanks,
So
Brian.
For testing, do you use mainly the including unit test for Python, or do you use any other libraries for testing, or is it?
I tend to lean more towards unit test, just because if you bring on another Python developer, then they should know the built-in testing tools. So for compatibility, that's good. I've used py.test in the past, and it's great. I do like it a lot. It makes things like you don't have to have the classes. It makes things super simple. So yeah, that's good as well. But yeah, typically just unit test. No?
It's not so much a question.
Sure.
So I think it's really important that you brought up the fact that you should test anywhere that's supposed to accept an exception, or anywhere that's supposed to expect an exception. There's been serious issues with the lack of testing in conditional exceptional code. For instance, the whole Eastern Seaboard long-distance network was knocked out when this AT&T code, which was propagated to all these nodes along the Eastern Seaboard, had an exceptional case that crashed the system. So it's a catch handler crashed.
Right.
And its catch handler sent out messages to every adjacent node to say, you have to fill in for me, I'm down. But it was the same handler catching those ones.
Okay,
so it caused
yeah.
mass propagation. And it's because they didn't test their exception handling code.
Yeah.
Probably because it's hard to test the exception handling code.
Yeah, it's very, very easy to skip.
You make it throw the exception such that you can actually write a test that catches the exception. Like printer on fire is a good exception that you might want to fake, because it's going to cost you a lot to test it in real life.
Totally.
I like it. I never learned about this mock object before, at least like it's cool.
Okay, cool. Aaron.
I just want to add a couple things, because I think this conversation about like why should I test seems to come up a lot,
Mm-hmm.
and for me there isn't a question there anymore, I guess. But just a couple points that come to mind from my experience. Testing means that 6 months from now I can walk back into that code and change something with a bit of confidence.
Yeah.
People say, oh, I test this to find bugs, or I test this so I know my code works. And I don't test for those reasons. I test because I know I'm going to have to go back and change things. And that's when I walk into the code base that has a change log and a test suite and all that, I automatically gain a lot of confidence in that code base.
Mm-hmm.
And I have something I can verify my changes with.
Yeah, definitely. I think it's something that there's a little bit of a learning curve to testing in general, but once you've got over that, or if you just make a big effort, then it's so much easier. I think particularly like if you're on a project that has a budget, and then you know you should be writing tests, but as soon as you start doing that, and then you kind of get the budget sort of dwindling a little bit, and then you're like, oh, I'll just throw my tests away and just concentrate on building the actual features because you just don't have time. But then I think if you can get to a point where you're confident enough with testing and can do it quickly enough, then you'll stick with it. I think that was sort of the way I found it. It took me quite a while to get to a stage where I was comfortable enough, and also know that you're writing your tests properly, and that if a test fails, it's not because the test has a problem, it's because your code has a problem as well. So there's a level of confidence that you need to get to, I think, with that.
I definitely found that once you start writing more tests, then it's almost like it fixes the code you're writing. A lot of times you write codes and it's not decoupled as it should be. And once you start writing a test, you notice it right away. So all of a sudden you're like, I'm testing two different things, and you tend to refactor a lot because you want to split those.
Yeah,
up.
definitely.
And so, especially at the beginning, you're just writing this mess of code, and once you start testing that, you see that right away.
Yeah, as soon as you start, like in that example with the decorator, as soon as you start stacking those up and you're like, I've got 5 decorators stacked up above my test, you know that you're doing something wrong. I try not to have more than 1 or 2, really.
So, in that example you had, your test, maybe I'm just like missing something because I'm not like the best with unit testing, but as you probably know, but
So I work with Kyle.
So your test now knows how that method was implemented, right? Like it knows that fetch HTML is using the requests library.
Mm-hmm.
Is that bad? Like, because now if you were to like, it's not very like black box, you know what I mean? It's like, it's kind of like and if you were to go back, like one of the nice things about unit testing is you write a unit test so that you can go back and refactor some code and make it nicer or work better. And if the test will pass, you're in good shape. But in that case, if you were to rewrite it using something else, you'd also have to update the test.
Yeah, so you could, like, I suppose, write a wrapper around requests so that then you could swap something in and out, and you'd be testing your wrapper, I suppose. But
is it just kind of not a big deal?
I don't know if it is for me. I mean, I suppose it depends how likely is it that you're going to swap something out. I mean, you have to consider you would need to write your whole layer on top. I mean, maybe if it's something like a billing system, I mean, there's a possibility that you could want to swap that out at some point, so I get that. But I don't know, maybe if I'm probably not going to swap out something that just like a library that hits the internet or something. Or is it, the question is it in the context of a business, is it like worthwhile doing that? So I'm probably not going to do that, so I would just write tests that do that, whereas something that's like mission critical, I might.
If I could add to that, Tim, I think I don't worry so much about, yes, the decorator does know about the internals of the method that I'm testing, but if for some reason I change that implementation, like I'm not worried about that. It's the rest of the test. The decorator allows me to test the rest of the stuff. So as long as that doesn't change, but I'm getting back my outputs or my other assertions as a result of that function, I'll probably end up changing that decorator to Euro or whatever else I'm using, whatever I changed it to.
Right.
So that the thing that I'm mocking isn't the thing that I'm testing. The thing that I'm testing, the mock just exists so I can test the other stuff. I guess.
Sure,
On
Nathan.
that topic, I've definitely heard to only mock things you own. Like if you were mocking the HTML Fletcher method, and then in a different using it, then you control that, and like it's your own method. You don't have to worry about like the syntax of how request works changing to version 4 or something,
Hmm.
and having to go change all these prompts.
Gotcha. Yeah, I've heard that too.
But I think part of it's just very simple.
Sure.
I argue that the patch decorator is a smell that suggests that you could use dependency injection if you're willing to invest the time to use dependency injection. So it's basically saying you lack the API to inject this dependency yourself,
Hmm.
so you're relying on that to do so. You got to do the economic analysis on it, decide if it's worth your time to provide a constructor that allows the dependency injection, and how much setup you got to do for that. Sometimes it's worthwhile to be able to inject your own. Otherwise, sometimes it's just a big waste of time, a big waste of code, especially if you only use it on a test.
Requests might be fantastic, we'll just use it for
I once lost 3 days trying to do some testing with a dependency injection. You know that thing where like you pass in like a list as a default parameter into a function and then it reuses the list. Yeah, so I had that with a HTTP library or something, and it was a night. It was so bizarre. Like the people were getting, and it was using an OAuth thing for Google Calendar, and then like people were getting the wrong calendars and stuff. It was horrifying, which you really don't want in a production app. Yeah. Anyway. Lesson learned. Okay, thanks a lot.